Right, good day class. Hey, yo. I get to explain that. Right, pane my definition, I can't say anything. Ndaka explain almost everything. A neutralization reaction is a reaction between an acid and a base to form salt and water only. Then the reversible reaction, though in order to do this sign, right? This sign. This is a reversible what? Reaction. And what is it? It's a reaction that goes on both directions. That is forward, which means this one, and also backward direction. Okay? Then dynamic equilibrium. Dynamic equilibrium is just a process or a situation whereby the rate of forward, which means the speed, right? The rate of forward, which means the rate of forward is the same with the rate of backward. The rate of forming a new compound is the same as the rate of reversing a compound into its reactants. That is dynamic equilibrium. Okay? Then there is what you call electrolysis. The term electrolysis, it means breakdown or decomposition by the means of electricity or using electric current or using electricity. That is the meaning of the word electrolysis. Zinongoreva breaking down tichishandisa magetsi. So when we are talking about electrolysis of water, this is actually the decomposition of water into its elements or into its constituents or into its reactants. That is hydrogen and oxygen using electric current. At primer level, we used to know that we can only separate water into its elements, which is hydrogen and oxygen, using this method called evaporation method. But this time at secondary level, we are being taught that we can separate hydrogen and oxygen using the electrolysis of water, which is the decomposition using electricity, using electrical current. Then number 6 was asking you to define reactivity series of metals. What is the reactivity series of metals? Reactivity series of metals, it means the arrangement of metals according to their readiness to react with non-metals. From the most reactive to the least reactive. For example, if I want to rearrange the metals in order of their reactivity from the most to the least reactive, I can do this. Poso, kama, zife, tilekos, which means potassium first is the most reactive, followed by sodium, followed by calcium, followed by magnesium, followed by zinc, followed by iron, followed by tin. Right? Then we move on and talk about ionic bonding. What is ionic bonding? Ionic bonding is a type of chemical bonding, right, where an atom either donate or receive electrons, which means in what we call chemical bonding, either one atom is going to donate, and when another atom is donating, it means another atom is receiving. For example, we have atom A and atom B. If atom B is going to donate, it means if atom A is going to donate, it means atom B is going to be the receiver, right? Is going to be the what? The receiver. So this one is going to be the what? The donator. So the type of bonding where an atom A that donate, for example, A is donating to B, or either an atom is receiving. For example, B is receiving from A. That type of bonding is called ionic bonding, right? Then there is another type of bonding which we call covalent bonding. What is covalent bonding? Covalent bonding is when atoms share electrons. When atoms share electrons, for example, if we have atom A and atom B like this, if atom A donates one electron, let me say 1 electron like this, minus. If atom A donates 1 electron to atom B, it means atom B, it must also donate 1 electron to atom A, which is a negative. Why? Because covalent is when atoms share electrons, right? Which means, in other words, covalent bonding is just sharing of electrons between atoms. That's it. If atom A gives 2, it means atom B is also going to give back 2 electrons. That's it. That is covalent. So the difference between covalent bonding and ionic bonding is that ionic bonding is when an atom either donate or receive. But covalent is sharing of electrons between atoms, right? Then we talk about valence. What is valence? When we are talking about valence, we are talking about the number of electrons an atom must lose or gain to obtain a noble gas configuration. When we are talking about a noble gas configuration, in other words, we are saying inamba yema electrons inofaniwa kugainwa kana kuluzwa ne atom kuti ive stable kana kuti iforme chemical bonding. Yeah, right? So valence is just the number of electrons an atom must lose or gain to obtain a noble gas configuration, or to be stable, or for it to achieve stability, or number of electrons an atom lose or gain to form chemical bonding. That's it. Right? There is what you call valence electron. What is valence electron? Valence electron is the number of electrons in the outermost shell. For example, this is the shell. For example, this is another shell. If we have 4 electrons, or let me say 5. So the number of electrons in the outermost shell, this is called the outermost shell. We all know that these are called energy shells or energy levels or shells, okay, or orbitals, okay. So the number of electrons in this outermost shell is called valence electron. Valence electron. Then more is a measure of an amount of a substance. Then isotope is an atom of the same element. Atom of the same element. For example, let me say we have carbon 12. Carbon 12. 6 electrons. Carbon 13. 6 electrons. Carbon 14. 6 electrons also. Right? What is an isotope? An isotope is an atom of the same element, carbon. It's same element, and it, right? With different number of neutrons. With different number of neutrons. You can add this definition. You can say with the different number of neutrons and also different number of different number of neutrons and also different mass number. That's it. But in a same proton number. This is proton number. As you can see, this is proton number, this is proton number. There is same proton number and the same element CCC. But zvakasiyana pa mass number E13, E12, E14. And also zvakasiyana pa neutron number. Neutron number, how are you going to get neutron number? You're going to say this mass number minus proton number, then we want a neutron. For example, upper, we have 6. This one minus this one, get 7. This one minus this one, you get what? 8. That's it. Then mass number or nuclear number, in number of protons and neutrons found in an atom's nucleus. Correct? In number, kubataniza ma protons nechi nema neutrons. Correct? Iyo mass number is equal to proton plus neutron. No formula yacho. Right? Then anode. Anode is the positive electrode where oxidation takes place during electrolysis. Ndinzwa. Daku explain zvimwe zvinhu zvarusinganzwisa. Right? Inonzi oxidation. Ndaona hangu vanhu pavanganyora test vanga vachidomoka singaita. inonzi oxidation. What is oxidation? Oxidation is going to addition of oxygen or removal of hydrogen, but this case is something else. Oxidation, it means loss of electrons. Loss of electrons. Loss of electrons. Oxidation, it means loss of electrons. So chinoitika pa anode chi. Let me explain, for example, the electrolysis of water. Chinoitika pa anode chi. When the electricity started to flow into the solution, ndakatsanangura this video kono gono check up YouTube panapa. Mangwa videos ndakasenda. Ndakatsanangura, you can go to YouTube kana kuti uri kuita lesson chat, you can go to YouTube or check at this video. And ndakatsanangura the electrolysis of water. Ndakataura kuti when the electrolysis or when the electricity started to flow into the solution called acidified water or into the electrolyte called acidified water, ndakati mean the anode lose electrons. And those electrons, they are being transferred from the anode, which is the positive electrode, into the negative electrode, which is the cathode. So you need to be careful. No particular, the anode is the positive electrode. Where oxidation takes place. Why did it where oxidation takes place? Because this is where electrons are being loose. Achienda kunonzi ku cathode. Which means cathode is a negative electrode where reduction takes place during the electrolysis. Why is it where reduction? Because the reduction, it means addition of electrons. So because cathode is going to gain electrons from the anode, therefore at the cathode, the reaction, the type of reaction that is going to happen there is called the reduction. And also because anode is going to lose electrons, and those electrons are being transferred using the electrolyte called acidified water into the cathode. Because anode is going to lose electrons, the type of reaction that is going to occur there at anode is called oxidation. Why? Because oxidation is loss of electrons, right? Then number 16, electrolyte. Electrolyte is a substance that is able to conduct electricity. Any substance that is able to conduct electricity, and that substance must be a solution. Right? Electroplating, a process whereby one metal is covered with another metal using electricity. Do inonzi electroplating. This is the best definition ever. Kunatika kota metal with another metal. That is called electroplating if we are using electricity. So ukasiya part ya electricity vamwenda chingo kumaka izvenyu, but ukasiya part ya electricity hazvinonyanya sokubuda zvakanaka, right? Then 3 definition of oxidation ndatozitsanangura kudharesha zvese ndazitsanangura. Right? Oxidizing agent. Chii chinobodza oxidizing agent? Right? Oxidizing agent is a substance that adds oxygen to another substance by removing some of its electrons. Right? Oxidizing agent, it can be a substance that adds oxygen. A substance that adds oxygen is called oxidizing agent. Right? Or a substance that removes electrons is also called oxidizing agent. Why? Because oxidation is addition of oxygen. So ukaskoka add oxygen uri oxidizing agent. Why? Because oxidation is loss of electrons. So ukaskoka remove ama electrons uri oxidizing agent. Same applies to reducing agent. Substance that reduces another substance by being oxidized. Right? Then hydrocarbons. These are compounds of only hydrogen and carbon. A compound is a new substance formed when 2 or more substances are chemically joined together. So in other words, hydrogen, new compounds are not formed one hydrogen and carbon. Do another hydrocarbon. Then element is just a substance made up of one kind of an atom, for example, carbon. Right? Compound is anangura. Apatak section B. How do we come up with the reactivity series of metals? Tingaita say kuti tiwane inonzi reactivity series of metals by comparing their readiness to react with the nanometals. Totobvaniza zvedine arrangement yedu. Wapedza. 3 optimum conditions for the manufacture of sulfuric acid. Question edenga listed down 3 optimum conditions for the manufacture of sulfuric acid. Right, my optimum condition for the manufacture of sulfuric acid, well known as the conduct process. We use vanadium V oxide as a catalyst. We use also 450 to 500 degrees Celsius as a temperature and 1 atmospheric pressure, right? Kuria good. Vanadium V oxide is a catalyst. What is a catalyst? A catalyst is a substance used to speed up the rate of reaction. A catalyst is a substance used to speed up the rate of reaction. Please, read this one from my lessons, chemistry. Remember, this is end of topic. Right? Why water is not added directly to sulfur trioxide during the contact process? The reason why it is but question and the answer is very simple. To avoid the formation of uncontrollable fog of sulfuric acid, which are difficult to condense. Or to avoid the formation of tiny droplets of acid, which are difficult to condense. Then by what process sulfuric acid manufactured industrial process manufacture sulfuric acid here the conduct process number up. Alright, state 1 use of a catalyst that in is to speed up the rate of reaction. Then name 2 raw materials and their sources used in the manufacture of ammonia. Right, my raw materials in this no ammonia. So tine nitrogen, tine wana kupi, that is the source. Tine wana kupi from fractional distillation of air, 1 or 2 marks. Then tine hydrogen, tine wana kupi from electrolysis of water, then 1 or 2 marks. Ma raw materials that no food from nitric acid, no shandisa, ammonia from harbor process and oxygen from electrolysis of water. State any 3 uses of sulfuric acid. Paper making, process. Maybe double check my questions that are so challenging. My raw materials, the blast furnace, name 2 products of the blast furnace, pig iron, you cannot cast iron, slag and calcium silicate. And why slag float on top of iron? That it is less dense. Describe the oxygen lens process. During the oxygen lens process, Tawana is slag cast iron in a pure. This one. So to remove my impurities. No partition on oxygen lens process. Oxygen lens process is used to remove my impurities from iron, which is well known as pig iron or cast iron. It is pig iron because in my impurities, and that's why it's pig iron. Right, oxygen is blown into the molten iron through a tube called a lens. Then this increases the temperature. And all the impurities are oxidized. My impurities react the oxygen over oxidized. Ammonia phosphorus, you have phosphorus oxide. Ammonia carbon, you have carbon dioxide. Then after being oxidized, they escape as oxides over Asia pure iron, which is 98% pure. So but 98% pure. Then no fuel is used because the reaction produces its own heat. No fuel is used because the reaction is exothermic, which means it releases its own heat energy. Why metals need to be coated? Why my metals need to prevent rust? Number 1. Number 2, for decoration purposes. How to learn 3 methods of coating that can be used in galvanizing, electroplating, painting. Why pure water is not used as electrolyte? Right? Why pure water is not used as electrolyte during the electrolysis of water? Why? Because pure water does not conduct electricity. Alright, name and 2 properties of an electrodes. My electrodes anofanonge akadaiso. Hafanonga achi conductor afanonga achi react an electrolyte. Does not react with the electrolyte. Number 1. Number 2, does not react with the product. Number 3, anofanonga achi conductor electricity. Name any 2 types of acids that can be used to acidify water. Sulfuric, hydrochloric. To make water acidified water. Right, name any 2 elements that can be used as electrodes. Carbon, platinum. Those are name characters I. Name the gas produced when an acid reacts with a metal and how do we test its presence. Right, gas no produce an acid react with a metal, renounce hydrogen gas. And to test hydrogen gas, we need a matchstick. And when hydrogen gas is present, it burns with pop sound. But when the amount of hydrogen gas produced is very low, it just extinguishes the flame. Name the gas produced when an acid reacts with carbonates and show how to test its presence. Kana acid reacts nemacarbonate inoproduce gas rinonzi carbon dioxide. Then testers say we use lime water, and when carbon dioxide is present, it turns lime water milk. That's it. Right? Give the differences between alkanes and alkenes. Right, my alkanes have single carbon to carbon bond, while my alkenes have double carbon to carbon bond. Ndokunonzi kupa my differences. How my differences ushinyora my points in points form. So I don't understand this way. This way not really very important. Why? Wapa first difference. Wapa 2 marks. Then alkanes have names that end in ane, whereas alkenes have names that end with ene. Ndatopana the difference. Wapa 2 marks foot. That's it. Electrolysis of biogas. Biogas roshanda in 3. That is heating, lighting, and cooking. That's it. Right. Name 3 factors that play an important role in the production of biogas. Znongo play an important role. It's role of temperature, role of pH, and role of bacteria. Explain what is biogas. Biogas is just a natural gas that is produced by fermentation of organic matter. Please, for more information, for more questions and answers, call or WhatsApp Mr. Marashanye on this number and on this one. Right, for those who want to join our online lessons, this is the number. Just contact me on this number. It's up to you. As you can see, among my questions in geography, questions about migration, just check. And these are the answers. Can I get more online lessons? It will be difficult for you to pass.
Right, greetings class. Today we want to do summary of industrial processes. Summary of industrial processes. So this is the chemistry section, and I'm going to try to do summary of industrial processes. Right, unofana kushandisa this acronym inonzi this is N, Sancho, VP, owner, show, 129, 459. So this acronym is going to summarize 3 industrial processes. Saka pana apa pekutanga pane anonzi ma processes here. Pane anonzi ma processes. Alright, then panotera up. Sorry, apa pane ma Sancho. This one is for products, sorry. It's for products. Here it's for products. Here it's for products. Right, and the second part here, this is for processes. And the third part is for catalysts. And ownership here, Jongo represent the same thing. This one is for raw materials. Right? And this part here is for pressure. And this part here is for temperature. Alright, so after explaining this, you'll be able to know at least these 3 industrial processes. Sakama products, we are referring to new things formed. New things formed, right? Then ma-processes tiri kuda zita reprocess rinotigadzirira ma-products atawana apa pekutanga. Then ma-catalysts. A catalyst can be defined as, let me just define it here. A catalyst is a substance used to speed up the rate of reaction, but remain unchanged at the end. Saka inonzi catalyst unofanira kutoiziva, so that ukataka kuzoti macatalyst unofanira kuziva kuti kutova nezvechii. Inonzi catalyst ringori substance rinongoita basa rekuincrease rate of reaction, kureva kuincrease speed of reaction. Anything that is going to increase the rate of reaction but not used in the reaction ndo inonzi catalyst. Kana kuti unogona kuti anything that is used to speed up the rate of reaction but remain unchanged at the end. Inoremaina unchanged how? Nekuti haisi kushandiswa pareaction but ringoshanda kungo speed up, but iyo kuti izopinda mureaction haisi kuita sei, haisi kupinda. Zvakafanana nemusikana anoda mukomana anoda musikana, akatya anotuma shamwari yake. Shamwari yake yonorongera musikana, yonorongera mukomana. Mukomana kana adiwa, shamwari yaya haina mabenefits ainozowana. Ndo kunonzi kuita catalyst. Ndo inonzi a catalyst. Right. Then tichibva ipapo toda anonzi ma-raw materials. Izvi zvinhu zvekuti any process tida kuita tofanira kunge tine chakati nechinoti. Handitika? Zvakafanana munhu anoda kudzidza, iye munhu wacho anofanira kunge aripo i-raw material. 2 anofanira kunge ane mabhuku. 3 anofanira kunge ane pen, ane penzo nezvimwe zvese zvikwanisiro, ndo anonzi ma-raw materials. Then pressure netemperature ma-conditions esa. Pressure and temperature ma-conditions. It's like kuti process iitike zvese tanazvo panodiwa chakati nechakati kuti zviite sei, zviitike. Saka ndicha explaina zvinhu izvi and ndoimba kuti unozvinzwisisa. Right, so tina sun tatanga ndi pana s apa kudai tetichireadha takadai semacolumns. Tiri kuti isusu sulfuric s, it represents sulfuric acid. So this s here, it represents sulfuric acid. So we are saying sulfuric acid is manufactured by a process called conduct. Sulfuric acid is manufactured by a process called conduct. Toenda pa catalyst. And vanadium V oxide is used as a catalyst. Saka kuri kuti sulfuric acid inomanufacture using the process called the conduct process, and catalyst inoshandiswa ipapo inonzi vanadium. Vanadium rikatingoti vanadium pentoxide ndosinganezi. Vanadium pentoxide kana kuti vanadium V oxide. Why ndati pentoxide? Because pent it means 5. Saka ndikati vanadium V oxide ndingoti vanadium pentoxide I one thing. Right? So that is sulfuric acid is manufactured by a process called the Conrad process, using vanadium pentoxide as the catalyst, oxygen and sulfur as raw materials. Oxygen and sulfur as raw materials. Saka O is for oxygen and S is for what? Sulfur. Then pa pressure pari kushandiswa 1 atmospheric pressure. Pa temperature pari kushandiswa 450 to 500 degrees Celsius. 450 to 500 degrees Celsius. Saka riga ndichitange. Handitika? See, sulfuric acid is manufactured by a process called the conduct process, using vanadium V oxide or vanadium pentoxide as the catalyst, oxygen and sulfur as raw materials, with the help of conditions such as 1 atmospheric pressure and 450 to 500 degrees Celsius temperature. Ndapedza. To summary manufacture of sulfuric acid. Saka wazati no manufacture ne process inonzi conduct process. Catalyst inoshanda vanadium pentoxide. Ma raw materials oxygen ne sulfur. Pressure 1 atmospheric pressure. Co temperature 450 to 500 degrees Celsius. Those nomerera first column. Let's now go to the second column. The second column rinana A. Toenda pana A apa. This is another column. Toda kuti tiri interprete. A uyu ari kurepresenta ammonia. Saka tiri kuti ammonia is manufactured by a process called the Haber process. And the iron is used as catalyst. Nitrogen and hydrogen as raw materials. The pressure is 200 atmospheric pressure. And the temperature is the same, 450 to 500 degrees Celsius. It's 450 to 500 degrees Celsius. Saka, ammonia is manufactured by the process called the Haber process. And the iron is used as the catalyst. Nitrogen and hydrogen, they are used as raw materials. 200 atmospheric pressure is used and 450 to 500 degrees Celsius temperature. Saka temperature ye manufacture of sulfuric ne temperature ye manufacture of ammonia yakatofanana. Tatupedza iri pa pressure nezvimwe zvese. Toenda pane the third phase. Unofanira kutozvinzwisisa zvinhu izvozvi chaiko chaiko. Toenda pa the last column. N uyu ari kumirira nitric acid. So nitric acid is manufactured by the process called oxidation. You know the oxidation. So nitric acid is manufactured by a process called oxidation process. And the platinum is used as catalyst. Platinum is used as catalyst. P uyakumirira platinum. platinum is used as catalyst. Ammonia yatawana paaba process here ndiye kutoshanda pa. Ammonia and oxygen are used as roach materials. 900, sorry, not 900, but 9 atmospheric pressure is used. Ndozviri kureva ka9. Saka pa pressure ye manufacture of nitric acid inonzi oxidation process, pressure iri kushanda it's 9 atmospheric pressure, but temperature iri kushanda apa iri very very high, it's 900 degrees Celsius. Hatitangiro handikuona zvatatendedza kuti apa ndiri kubata 9 pakafanana temperature yati ndeipana sulfuric acid naammonia, but panitric pari kushanda 900 degrees Celsius ndori kushanda as the temperature. Pressure iri 9 atmospheric pressure. Raw materials ammonia neoxygen. Catalyst inoshanda inonzi platinum, then process yacho oxidation. Product chiri kufomewa chacho nitric acid. The summarize the manufacture of sulfuric acid, the manufacture of ammonia, the manufacture of nitric acid. But there's something that don't explain chiri very very important. Let's draw it. Let me just do this. Ndoda kuti uziye ma sources of ma raw materials. Oxygen yatachiti oxygen inoshanda pa conduct process here. Inobva muprocess inonzi electrolysis of water. Alright, tikandida so tongonyora ese ma raw materials. Anitachiti pichana chakati ne ese raw materials. Saka tine oxygen tete hydrogen. Ma raw materials are 2. Anobva ku source where they are coming from. And oxygen inoshanda pa manufacture nitric acid igoshanda futi pa conduct process, but where is that oxygen coming from? Ndati kuti source inobva ku process inonzi electrolysis of water. Handitika zviri kubatika izvo, right? Koita nitrogen. Nitrogen inobva ku fractional distillation of air. Ndokuri kubva nitrogen. Saka ukanyoziya zvinhu zvokubatsira kuti pa conduct process toshandisa oxygen inobvepi from electrolysis of water. Kwa hydrogen inobvepi electrolysis of water again, but I'm not saying hydrogen inoshanda pa manufacture of sulfuric acid. Ndingotaura kuti ukashandisa hydrogen as a raw material iri kubva from electrolysis of water, then nitrogen kubva from fractional distillation of air, ndokwairi kubva. Then pane patati sulfur pa conduct process because tati pane ma raw materials anoti sulfur neoxygen. Ko sulfur iri kubvepi? Sulfur iri kubva from iron pyrites. Iron pyrites. Those sources ndokwazviri kubva. Saka unofanira kuziya ma sources. Koita atinoti isusu ma optimum conditions. Ma optimum conditions ndo atati chiti isusu chakati temperature yakati catalyst yakati nditi zvafanana ne conduct process. Ma optimum conditions acho number 1 tati temperature ye 450 to 500 degrees Celsius temperature. Ndo first optimum conditions. Number 2 tikati chi vanadium pentoxide i-catalyst. Tikati 1 atmospheric pressure. ndo anonzi maoptimum conditions. Saka number 1 tine temperature, pacontact process tine temperature 450 to 500 degrees Celsius. Then number 2 tine vanadium pentoxide iri catalyst, tine 1 atmospheric pressure. Ukanzwa maoptimum conditions eHaber process, temperature unofanira kuziva kuti ndeimwe chete 450 to 500. But manje pacatalyst apa pane ion as a catalyst. Then pa-atmospheric pressure that is 200 atmospheric pressure ndeHaber process. Toenda pane oxidation process, maoptimum condition oxidation process. Apa panopinda 900 degrees Celsius temperature. Popinda chimwe chii futi, platinum as chi catalyst. Popinda chi 9 atmospheric pressure. Ndo ma-optimum conditions. Question inotoya kuti list down the optimum conditions in the contact process. Unongo list ari 3 wire. In the Haber process ari 3 wire. In the oxidation process ari 3 wire. So that's it for today.